Currently, the pile fails in both moment and the embedment requirement. To address these failures, we can do a variety of things. For example, we can increase the embedment depth, we can increase the size of the pile, reduce the spacing of the piles, use tiebacks, or do a combination of these ideas. For example, I can increase the size of the pile to a W14 by 99. Let's click on the General tab and then click on the database, and we pick a W14 by 99. This fixes the moment capacity issue, but it does not fix the required embedment issue. However, it helped in terms of the required embedment, meaning we originally needed about 35 feet of embedment, but now we only need 24 feet of embedment. Now is the perfect time to cover a tieback example. Let's add one tieback at 3 feet from the top of the retained soil. Let's also change the bottom of pile to be pinned instead of fixed. Also, at the bottom, we used to have only two options, either fully braced or completely unbraced. Now that we added a tieback, you can get an option to say, consider the pile to be braced at tieback locations. For this example, we will keep this pile completely unbraced. Let's switch to the 2D sketch view by clicking on the Construction tab. You can clearly see that the tieback is represented in red in the sketch, and it is indeed located 3 feet from the top of the retained soil. Based on this, the required embedment is reduced significantly to about 4.6 feet. To evaluate the results, let's click on the Summary tab. You will see the same values reported, such as lateral loads, shear and moment values, etc. However, there is a new section called Reactions. This is the reactions from each tieback. In our example, we only use one tieback, and the reaction is 35,193 pounds. You can also see the base reaction as well, which is reported as 11,207 pounds. Under the status checks, the stress ratios are very low. This means we can reduce the pile section. Let's change the section to a W12 by 30. We glance again at the stress ratios, and they are acceptable. Due to changing the pile section to a smaller size, ENERCALC recalculated the required embedment, and now it needs to be 6.84 feet. The current max deflection is 0.27, which is acceptable for the purpose of this example. The last thing we need to do to finalize our design is to change the total pile embedment on the left side to something smaller. We will use 8 feet. Now that we've fully finalized our design, we can use a W12 by 30 at 8 feet on center with one tieback 3 feet from the top with 8 feet embedment. Overall, the soldier pile retaining wall module is a powerful and useful module for those involved in shoring design. It provides a great level of flexibility and granular control for the user to address their unique conditions. If you like to learn more or have any questions, you can visit our website, enercalc.com, or send us an email at support@enercalc.com. Thank you for watching.